How's it going, folks? This is going to be a video on adding this hydraulic thumb to what was designed to be a standard mechanical thumb setup on a 1-ton mini excavator. So your hydraulic thumb assembly comes like this, and there are a couple options for installing it. One recommendation was to cut out the bottom two holes right here. That way you don't have all this metal in the way, and then bolting this hydraulic cylinder into this last hole here. But this leaves you an issue. Your thumb is almost at a 90-degree angle to this plane of this beam of this arm here. So what we want is, I want that hydraulic thumb, I want it all the way retracted when I pull it back. But to do that, I have to move this hole that I mounted in back one. So I'm going to cut right down here, break these welds, grind this flat, and move this back about an inch here. So my goal is, when I have this all hooked up here and the hydraulic thumb retracted, it will be looking something like this, as flat with this plane here as possible. That way it's not hanging down and getting in the way of any digging that I'm doing. There also is a part out there that you can buy that bolts in to the bottom and top hole. It comes out over and has the attachment point for the hydraulic cylinder, so it holds it up like this. That's another option, but for this machine, we're not going to be going back to mechanical thumb, so it's really there's not much loss if we take this off. And if we really want to, we can put some find another set like this to put on here. This isn't a hard piece to make. So our plan is to move this hole back about an inch. I'm going to cut this off, and then I'm going to measure it up using this to actually figure out where I want to put this hole to mount this, because I want to physically see it first before I do any welding. So what I'm going to start doing is I'm going to hit my angle grinder, and I'm just going to cut along here, cut out this weld. You have the continuous weld on the outside, and then about 2 inches of weld on the inside. So we'll see if I can get this cut without cutting into the base metal. Okay, so I'm going to change over to a 40 grit flap wheel, and I'm just going to use this to remove the weld beads here that I wasn't able to cut through. I may have scored it a little bit, but I didn't cut into the base material at all. I kept a really flat plane with that angle cutoff disc, so cut straight in and didn't dig into this base plate here. So I'm just going to come in here, clean up these welds, make everything as flat as I can, and then sand off up here, because up here is where I'm going to be adding those brackets. I'm finding the more I do these, throw these things away when I start to get worn down. I used to look at this and say, hey, there's a lot of meat left on this, I can keep using it. Throw them out. Same thing with flap discs. I would go until the last piece of grit was on here, and all you end up doing is burning your material and burning up your tools. So it's, the more I do this stuff, the quicker I am to throw away consumables. I used to think that was very wasteful, but the older I'm getting and the more I'm doing it, the more I see why people do it, who do this for a profession every day. Make a mark up here. This is just telling me where it was to begin with. This way I have some sort of visual representation that I know where it was. I just like making marks, kind of capture my progress, so if I need to go back for some reason to do measurements, theoretically I'm not going to need to do that, because it's all going to be measured off of how that thumb sits in the geometry of that hydraulic cylinder. But it's always good to mark where your old piece was before you eliminate all evidence of where it lived. Alright, I have everything mocked up. So I have the two brackets that I cut off the original thumb mount and cut them, ground them down to where they're not going to be hidden into the hydraulic cylinder. I used the original pin that was in this bracketry, so I'll swing it around this way. It's just one of these ones that you'd use a bolt and you bolt it in. That keeps the pin from moving. And just have a clamp here holding the bracket close to the arm there. Down here, I just took one of these magnets. This is supporting the weight of the thumb, so it's not dragging it down. So my idea here is to tack these two on here and then hook up my hydraulic hoses, make sure that this thing has full range of motion and that's not hitting anything, and kind of do a couple test runs just to see, hey, is this the proper geometry for this? As you can see, this is the folded position here. I could probably take it up a little bit more and have it closer up this way toward the arm, but I like that it's a little bit further down, it's still out of the way, and the further down you have it in a stored position, the further down it's to be able to curl when you have that bucket fully retracted back. So just makes it a little bit more useful in my opinion. So what I'm going to do, I'm going to set this up, do some welding, hook up some hydraulic lines, and we'll go from there. I don't know if this is completely necessary, but I'm going to bleed these lines before I hook them up, just because I don't want a bunch of air in here. That test right there, my hydraulic cylinder was hitting this pin right here because as arch is down, the cylinder bottomed out on this pin here. So I need to move this up just a little bit here. So this is at full extension here. I like this because it's not just off the pin, but it's off of this bracket here. So say if we forget putting shims in here or this whole assembly moves, I don't have to worry about running this cylinder right into this bracket here. It's going to stay off of this. So I like this height right here. This keeps it at a, you know, good height. Thumb comes down to a usable position here, and it folds way up out of the way. So really happy with this. So I'm just going to make sure everything's squared up, level, and the way we want it. Then we'll get it welded in. Alright, got our welds all done here on our bracket, so that's cooling. So down here, as you can see, the thumb, the whole assembly, can move from side to side. So what I've done, measured this, is comes out to 1.185, I think. I'll double check that. So I need to make two spacers here, one to go on each side. I think it's like come out to like 0.585, I think is what I got for them. And so we'll put basically a 1/2 inch spacer here, 1/2 inch spacer here, and that will keep this thing somewhat in the middle. So we're gonna go over to the lathe here, and I found a chunk of aluminum, which will work just fine for this. Aluminum's would be perfect. It's not going to be taking that much force, and it's not going to rust. That's the thing I like about it. Smaller parts like this are a little bit harder to get centered in here, but it looks pretty good. So here's the finished product. So you can see there's the brackets all welded in, and I painted all the exposed metal that I had here. I just painted it black. The reason I chose to do that is trying to color match this would prove to be difficult. I do have to do a little touch up there, but I just taped everything off so it'd look symmetrical. Greased everything so that it doesn't rust there, and yeah, really happy with how this came out. I just tested it out. It works good. Geometry is good, and yeah, really happy with it. One thing to bear in mind if you're looking at getting one of these hydraulic thumb kits is you need to buy an adapter for this. So I'll put it up on the screen here so I don't butcher it, but this hose was bigger than the one for the thumb, so I had to get an adapter kit there to make that work, and I believe that was around 70 bucks for 2 of them. So I don't know if you can find them cheaper other places, but that's why I ended up paying for mine. So just bear in mind that not all the hoses on these are going to be the same size. So anyway, hopefully this answers some questions for you guys, and thank you guys for watching. Have a great day.